Storyline 1, search for life. What do we need for life on this planet, and how does it affect looking for life on other planets? Lesson 7 focuses on, is water a salt? For today's lesson, you need this note sheet. So if you do not have it, go get it. So what did we do in the last class? Well, we figured out that we can predict the formulas of salts based on an element's location on the periodic table, because elements in the same column like this had the same charges. They had the same dots in the Lewis dot structure. Okay, they had the same outer or valence electrons. So elements seem to be grouped in vertical columns based on their outer or valence electrons. So what do we know about water? What is the chemical formula for water? What do we know about the atoms that make up water? How are the atoms in water arranged? What do you know? So let's go over some of the important details and ideas about water. So water's formula is H2O. That means it has 2 hydrogens and 1 oxygen. Hydrogen has 1 singular proton and 1 singular electron. Oxygen has 8 of each. Hydrogen has a 1 valence electron and oxygen has 6. Why 6 and not 8? Because 2 of oxygen's electrons are in an inner energy level and they do not participate in bonding. We've been seeing water represented with this bent shape where oxygen is up here in the middle and the 2 hydrogens on the outside. And in the last lesson, we learned about the tendency of atoms to combine and bond with ionic bonding in a way that leaves them with a full outer valence energy level. And they did that by 1 atom would lose electrons and 1 atom would gain. So let's try to focus on how the bonds form. So let's use what we learned before about how salts form to make an initial model of how the bonds might form in water. So here are the atoms that combine to form water, because remember the formula is H2O. So on your notes right now, build a water molecule using the same process that forms salts. That means electrons need to be lost from an atom and gained by an atom. So make the model. So based on what we learned previously, this is what your model should look like, which means 1 hydrogen atom loses an electron and it's gained by oxygen. The other hydrogen also loses an electron and it's gained by oxygen. So both hydrogens end up with a +1 charge and oxygen ends up with a -2. So let's think, does this seem like a likely explanation for how water forms? Do you think hydrogen loses its electrons to oxygen to form a salt like we've seen with our other models in the previous lesson? So let's think about it. Let's talk about the strengths and the weaknesses. So this is what the model looks like, right? And a plus. Oxygen has a full set of valence electrons. Look at it, 8 dots around it. The charge is balanced. What does that mean? Well, you have hydrogen with a +1, another hydrogen with a +1, that gives me +2. And then we have oxygen with a -2, and that gives me water with an overall charge of 0. 2 thumbs up for those. But I have some questions. So first, can hydrogen have 0 electrons? So remember, hydrogen had 1. And when we talked about when salts were forming, the goal was to get a full outer energy level. So does that mean losing and having none? I don't know. And is hydrogen a metal? So think about metals, right? And we know that salts were formed from a metal and a non-metal. So hydrogen as the positive cation, is it a metal? So can it form salts in the same way? So let's make a prediction. Do you think water is a salt? Why or why not? Write your answer in your notes. What do you think? And remember, predictions do not have to be accurate, but they have to be based on some reasoning. So do you think water transfers its electrons and bonds with ionic bonding to make a salt? So write your prediction. So let's go through some of it. So remember these salt models that we worked on in a previous lesson and look at how they are modeled. with the negative ions and the positive ions. Is this how you have seen diagrams of water represented? Remember the salts that we investigated in lab, how they were solids at room temperature, and then we could dissolve them in liquid like water? And you know how water is a liquid at room temperature. Seems a little different. Okay, remember salts are electrolytes. So in their solid form, they didn't conduct any electricity. The conductivity meter showed no electricity flowing. But then when we dissolved those same salts in water, they did conduct electricity. So when you take a salt and you add water and dissolve it, you get conductivity. So water and salt is conductivity. But if you add water to water, you don't get any conductivity. And then the whole hydrogen thing. So remember, salts were metal and non-metal. Well, hydrogen is unique. It only has one electron. So if it loses its one electron, it doesn't have any, and that's really not a preferred state. So hydrogen is a non-metal. So why the heck is it over there on that side of the periodic table with the other metals? Well, just because it is in the same column as other elements with one valence electron. But hydrogen behaves like a non-metal on the other side of the periodic table. So we kind of can see that water and salts have very different properties. So do you think water is a salt now? And remember, our predictions don't need to be accurate, but we're working through the science. So based on all this information, the model for ionic bonding using electron transfer doesn't really seem to fit for water. It seems like we need a new model to explain how the bonds form in water. So let's review a little bit. So I'm going to get my pen here, okay? So let's review the energy levels. Let's look at neon. So do you see this right here from your periodic table? This is a 2-8. So this means 2 electrons in the first energy level. So this right here represents the nucleus with my protons and neutrons. So here I have 1, 2 electrons in the first energy level, and then I have 8 electrons in the second. And I go through and I count these all around here, and that's 8. So let's look at potassium. Similar idea. This says, though, 2 in the first energy level, then 8 in the second, then 8 in the third, and 1 in the fourth. Ooh. All right, so here's the nucleus, which is where we would have protons and neutrons. How many? This many. So the charge of this nucleus would be plus 19. Okay, then we have 1, 2 in the first energy level, then 8, and then 1. And this represents the valence electrons. So here's hydrogen. It literally only says this. So that means it has 1 electron in its only energy level, the first one. And then oxygen has 2 electrons in the first energy level and 6 electrons in the second energy level. And you can see that represented here. So now let's look at the notes. How many electrons does hydrogen need to have a full first energy level? How many total electrons does it need? How many electrons equal a full first energy level? 2. 2 electrons is a full first energy level. So think about now, how many electrons does hydrogen have right now? So how many does it need to gain in order to get a full energy level? Well, it needs to gain 1. So now think about the second energy level. How many electrons does oxygen need to have a full energy level? Well, in matter of fact, any element have a full second energy level. Well, that would be 8, because if we look, the second number is always 8, okay, when it's full. So how many did oxygen have right now? It had 6, but it needs 8. So how many does it have to gain? 2, okay? So if hydrogen and oxygen cannot use electron transfer to get their outer energy levels, what other option might there be besides transferring? What else could they do? So let's try making a water molecule by sharing instead of transferring. Okay, so try and make a model where you show sharing, and then we'll look at it and you can supplement, change, add based on what we look at together. Okay, but instead of transferring, they want to share. Okay. All right, so what you should end up with is something that looks like this. And I will, in this model here shows pretty well how to get there. So here we start with oxygen, and it has 6 valence electrons. And look, this hydrogen is like, if I brought my electron right here, and this hydrogen is like, you know what? If I brought my electron right here, we would end up like this. So here it is represented with all the dots, which is standard how we've seen it. But for this type of bonding, we can show 2 shared electrons as a line instead of dots. So both of these are correct. And we can see them represented a few other ways. For some reason, the Regents exam accepts this model right here. I'm not a fan of it because it does not show bent shape, but it would be accepted. Here, we're using dots to show the oxygen, and then X's to show the electrons that come from hydrogen. That is okay, but you have to be careful because if you put the dots or the X's in the wrong spot, you would get it wrong. If you just have them all be dots, then it can be a little bit less confusing. And then here are just some models showing what it looks like molecularly and what it would look like with the Bohr model. So let's answer some questions about this model. If oxygen and hydrogen share electrons, do we think these electrons, the ones that are in the box right here, right? Do we think these electrons count for hydrogen, oxygen, or both? Yeah, those electrons only count for oxygen. All right, what about those electrons? Do they count for hydrogen, for oxygen, or both? Yeah, those ones also only count for oxygen. So what about those electrons? Do they count for hydrogen, for oxygen, or for both? Well, those ones count for both because they are between the 2 atoms. And then what about these electrons? Do they count for hydrogen, for oxygen, or for both? They count for both because they are between them. So what does this show us? That shows oxygen has, ready? 1, 2, 3, 4, 5, 6, 7, 8 electrons around it. Perfect, loves it. That is a full valence shell. So what about this hydrogen right here, right? This one has 1, 2, and for hydrogen, that's full. It's perfect, beautiful, loves it. Okay, and then what about this hydrogen? Well, it has 1, 2, beautiful, perfect, full outer shell, loves it. So all of the atoms end up with a full valence shell by sharing instead of transferring. This new type of bonding where electrons are shared is called covalent bonding. So transferring was ionic, sharing is covalent. And in the next part of this lesson, we're going to investigate that more.